For this series in Spacecraft Guide, we are going to focus on the Space Shuttle. We're going to concentrate on the flight instruments to teach you how the astronauts flew the Space Shuttle in flight and in orbit. In this issue of Spacecraft Guide, we're going to continue our work on teaching you how to fly the Space Shuttle, and we're going to focus again on the instrument that the astronauts used to determine the condition of their spacecraft for navigation and spatial orientation by focusing on the primary flight display. And when we click on it, it takes us to the primary flight display page. Now we're going to focus again up here on these displays, which tells us what the computer is thinking. And we're going to focus here on this one right here. This one that says ATT LVLH, and that is the ADI attitude status display. And when you click on it, that goes to the ADI attitude status display. Now, what this does is it provides a continuous display of the unit's frame of reference, okay, which are internal, local vertical, local horizon, and reference. Now, what do those mean? Now, internal means the position allows the flight crew to view the orbital's attitude with respect to the inertial reference frame. Now, that's useful for locating stars. So what they're doing is they're setting up this instrument right here with a bunch of stars to which could be stars, to give them an independent reference frame of what they want to navigate by. The next is the LVLH, and that position, it shows the orbital's attitude from an orbiter-centered rotating reference frame with respect to the Earth. Now, this, as you can see, is going to be with respect to the Earth. It's upside down because we know that because the white should be on top. So this is reference to the Earth upside down, and that is here in the master mode. It's 103. That means we're still taking off. We're getting into orbit, and we're upside down on our back getting into orbit. And you can see there's the horizon. We're a few degrees up, pointing, getting into our orbit. So that what LVLH, and then the reference position is primarily used to see the orbital's attitude with respect to an initial reference frame defined when the flight crews last depressed the attitude reference push button above the attitude ADI switch. The reference position is useful when the crew flies back to a previous attitude or monitors an OMS burn for attitude excursions. Okay, so let's look at this one here. It gets a little difficult. This is your reference position. You put the reference position in here by selecting a push button. And when that does, it sort of freezes. It's like if you're playing a simulator and you freeze the sim in a position that you can come back to it. That's basically what you're doing. Or if you're on Google Maps and you put a pin in it. So this is basically putting a pin into where they are in orbit around the Earth. Now, why would you want to put a pin in? That's in case you want to get back to that attitude. When would that be useful? Well, let's say that you need to go to a specific attitude to, you put a sample in space, now you move to go somewhere else, and you want to come back to that sample that's in orbit in space and pick it up. That's where this would be useful. Now, the other one they say here, I love this, they use their term, monitors for OMS burn for an attitude excursion. Oh, wow. Attitude excursion. What is an excursion? It means you're leaving an attitude. attitude. You're going from maybe you're going from docking with one satellite to docking to another, so that you're doing an excursion to get to another satellite. So that's what that all is for the attitude ADI attitude status display. Now, for our Patreon subscribers, even the free ones, the ones that don't cost you anything, we're going to go deeper into the schematics. So, if you are a Patreon subscribers, including the free ones, which you can join up right now and see what I'm going to go into, if you click on schematic,